Hey there. Today we're going to wire our first circuit. And this is what is so exciting about this whole world of microcontrollers and robots. Is it's one thing to write a computer program, but what's really cool is to be able to act on the real world, to be able to make a physical impact on the world. And that's what's great about the Arduino and all the other microcontrollers we're going to talk about. The Arduino has the ability, after you write programs and put the programs on here, to act on motors and servos and lights and things like that. And it's really awesome, and then the possibilities are endless. So today is going to be our first circuit. The circuit we're going to wire is going to be a simple LED. And the reason we're going to start simple because I want you to see how simple it is for the Arduino to do digital input and output. On the Arduino, there's a series of pins on the side that are GPIO pins, or general purpose input-output pins. So they're general purpose. They can have input where they can receive digital data, and they can have output, they can send out digital data. By digital, I mean it's a 1 or a 0. It's on or off, high or low, 5 volts or ground, depending on what your logic is. Okay, so let's wire up our first circuit. We're going to wire up an LED, a light emitting diode. We're going to have a small red LED. And one of the first lessons we're going to see is that everything we wire needs to be a circuit. And just like the word implies, a circuit means a complete loop. And any electronic system you've ever heard of, everything from lights to computers to your own brain and your own muscles, is a circuit. And the way a circuit works is current, which is a flow of electrons, flows from a place of high voltage to a place of low voltage. In the case of Arduino, it's usually 5 volts, or sometimes what we call high, down to ground. And that is a complete circuit. So the circuit is electrons going up to 5 volts or high, and then going through whatever we want, in this case an LED, to ground. And that's how we're going to do it. So let's get started. We're going to use a breadboard. Breadboards are great because they allow us to easily connect wires without any kind of solder or other kind of permanent mechanism to connect the wires. So we're going to take a breadboard and we're going to wire up our LED. An LED, light emitting diode, it's just that. It's a diode, which is an electrical component that allows current to go one direction, and that's important. LEDs, like all other diodes, only work in one direction. In the case of most diodes, most LEDs we're going to work with, one of the legs, and it's hard to see, one of the legs is longer. Current's going to go from the long leg to the short leg. That's important to remember. So we're going to use our breadboard to wire up an LED. On a breadboard, the rows are all connected to each other, and that's how we connect wires. And also on the sides, there are long columns of holes that are also connected. That sometimes is really useful. They're colored. Most breadboards I've ever used are colored red and black or red and blue. And those are the convention is to use red for 5 volts or high and blue or black for ground. That's the convention. So I'm going to take my long leg. I'm going to put my long leg over on the left, and my short leg is on the right. Now I'm going to put a resistor in line with my LED. Two things to note here. You always need, I would say always need a resistor when you're wiring up an LED. Here's why. Once an LED has enough voltage across it, and we can talk more about voltage later, once an LED has enough voltage across it to turn on or to allow current to flow, a lot of current can flow based on how much voltage. In fact, so much current that you'll fry your LED. So a resistor is just a small element that controls the amount of current. We'll talk a lot more about Ohm's law, but basically the amount of current is proportional to the voltage divided by the resistance. And if your resistance is very low, you'll get a very high current. That's sometimes written mathematically as V equals IR. So we're going to apply some voltage to this LED. We don't want too much current to flow. We don't want to cook it. So I'm going to put a resistor in line with it. Now, the resistor can be anywhere in the circuit, because if you think about it, electrons are trying to flow through my circuit. I can put a resistor anywhere in that circuit and it'll slow down the current everywhere. I often think of circuits as plumbing, And if anywhere in your plumbing there is a restriction, the current flow or the water flow will be reduced everywhere. So let's put a resistor, just pop a resistor in here, just anywhere, like I said, anywhere in line with the circuit. So I'm going to have current flow through the resistor, through the LED to ground, and that's going to be my complete circuit. Let's wire up ground. I like to use black for ground. Obviously, these wires, the color doesn't matter, but by convention, I'm going to use black. And then by convention, I'm going to use red for 5 volts or high. So here's my circuit. I'm going to have current flow from the Arduino through this wire, through the resistor, through the LED, back to ground. That's my complete circuit. Now, obviously, I could actually hook this up. In fact, I'm going to do that right now. I'm going to hook my black wire up to ground and my red wire up to 5 volts. And my LED comes on. I don't need a brain or I don't need an Arduino to do that. I could use a battery to do that. I've just got 5 volts running through this wire, through my resistor, through my LED, back to ground. That's my complete circuit. Where the brain or the Arduino is going to come into play is I'm going to use the smarts of my Arduino to do something special for the LED. In this case, we're going to make it blink. So let's do that. Instead of plugging my wire straight into 5 volts, I'm going to plug it into pin 8. I could plug it into any one of my digital I/O pins. In this case, I'm going to plug it into pin 8. Now I'm going to tell my Arduino, I'm going to write code to tell the Arduino to turn on and off. Let's do half a second just for fun. I'm going to tell my Arduino to turn pin 8 high, that's 5 volts, for half a second, then turn off for half a second and do that indefinitely, and that will complete our first project. So let's do that now. So I'm going to open up my Arduino IDE, just like I've done before, and as I've explained before, we have to have 2 functions in every Arduino sketch: void setup and void loop. Now remember, any function has a couple things important about it. The void keyword just says this function isn't going to return anything. Later we'll probably write some functions that return stuff, but for now void just means no return. The empty parentheses means the function doesn't receive any information or receive any arguments or data or things like that. Both void and setup have empty parentheses. You need the parentheses even if you're not going to receive anything. And then the curly brackets enclose the whole function. So I have 2 functions. Everything between these 2 curly brackets is going to be setup, and everything between these 2 curly brackets is loop. At the top of my code, I like to define any variables. Variables are little pieces of memory we're going to set aside, little keywords or little numbers or things like that we want to use in our program. And not just variables. Variables, they vary, and a lot of times the logic of your program will change those variables. Also constants. In this case, I'm going to define a constant. And I like to use the define keyword. Now in Arduino programming language, which is a variable of the C programming language, the define is nice because what it does is when I define something like LED pin, and I'm going to define it as 8. Later in my code, every time the compiler sees the word LED pin, it's going to replace it with a number 8. It's nice and efficient, makes everything run nice and smooth. You don't have to do that. Sometimes at the top, I can just define an integer, LED pin equals 8. Either they're essentially equivalent. The advantage of defining, like I said, it saves a little bit of memory, but either one of those would work. We'll get more into data types later, but this second line I have here defines my LED pin as an integer, and the Arduino programming language needs to know what data type all your variables are. And by data type, I just mean, is it an integer, like a whole number, or is it a float, which means a decimal number, or there's other types there are other data types like booleans or true or false, and strings are text, but we'll get more into that later. So I'm going to define my LED pin as 8. In setup, I only need to accomplish one thing in setup, and that's to tell Arduino what pin 8 is going to be doing. And I do that by using PinMode. PinMode defines LED pin as an output. Now, like I said, the pins on the side of my Arduino are GPIO, general purpose input output. Arduino needs to know, am I going to use pin 8, LED pin, as an input or an output? In this case, it's an output. Now that I've said that, down in my loop, I can actually utilize the pin. I'm going to use a DigitalWrite function. DigitalWrite is a function that Arduino knows, and it tells the Arduino what to do with that pin. And first I have to tell it which pin, it's the LED pin, and I'm going to say make it high. I could actually compile my sketch right now, and I'm going to do that because I like to, as I'm writing code, I like to see if it's working. So let's see what happens when I say DigitalWrite high. So I'm going to upload my sketch. It's going to hopefully upload if I've told it the right serial port. It looks like I'm on COM42 today. It's compiling and uploading, and once it uploads, hopefully it'll turn pin 8, and if I've wired everything right, it'll turn pin 8 on. Uploading, and there it is. Pin 8 is now high. So if you look at my code, nothing too exciting. All I've done is say DigitalWrite LED pin high, and LED is pin 8. Now, next I want to make it blink, so I'm going to make a delay, and I'm going to do half a second, which is 500 milliseconds. Then I'm going to turn the pin off. Low. Gotta type low. And the last thing I'm going to do is delay another half second before my loop goes back to the top and turns the pin on again. So if I upload this, every half a second, I should see the code. I should see the LED blink. On, off. That's every half a second. So if you take a look at the code, I've defined a pin, defined a constant LED pin. I've set my LED pin as an output. Then in my loop, which is going to run all day long, I've told it to be high, which is 5 volts. That's turning pin 8 on. Then I'm going to wait half a second. Then I'm going to turn pin 8 off. I'm going to wait half a second, and my loop's over. It's going to go to the top of the loop and start all over again, and I have a blinking LED. Pretty awesome. I've written code that's making real things happen in the real world. That's pretty cool.